Today we are going to discuss about the worksheet that I have shared with you. Topic was giant covalent compounds. You have to fill these blanks. Both dash and dash dioxide have a dash structure. Dioxide is showing that what you have to write. We are talking about giant covalent compound. So I have discussed with you 3 giant covalent compounds. Graphite, diamond, silicon dioxide. So what you can write in these two blanks?
Yes, Can I?
Yes, Ibad.
Both diamond and silicon dioxide.
Yes. Diamond and silicon dioxide having a similarities in their structure. So that's why you can write here, because next sentence is completing it. Both diamond and silicon dioxide have a giant covalent structure, which is a very large 3D. So you have to write here diamond and silicon dioxide have a giant, because the topic is giant covalent compound, so you can pick from that giant covalent structure. Next blank having covalent structure, which is a very large 3D dash of atoms. 3D dash of atoms. What will be the answer? 3D network of atoms. There are atoms, those are joining together in a 3-dimensional structure. So there is a network of atoms. Network of atoms held together by dash covalent. Which type of covalent bond is present between silicon dioxide, silicon dioxide and diamond? Strong covalent bond. In graphite, there are intermolecular weak forces are also present, but in diamond and silicon, there are just strong covalent bonds are present. Strong covalent bonds. G. Abdurrahman, you have to answer this. Diamond has a dash covalent dash.
Strong covalent.
Giant covalent
structure
with strong dash bonds. Which bonds? Which type of bonding are present between diamond atoms? Strong dash bonds.
Covalent bonds.
Yes.
Covalent bonds.
Yes, covalent bond with strong covalent bonds between the atoms. You have to write here between the atoms, which need a lot of dash to break. What
Energy.
is needed to? Yes, energy. Good beta. Needs a lot of energy to break. Diamond is very dash, as each carbon atom is held in a rigid dash arrangement. Diamond is very dash. See, Ibad, diamond is very dash, as each carbon atom is held in a rigid dash arrangement. It's very hard. If you revise all the lectures, you will get that I explain again and again that diamond is very hard, as each carbon atom is held in a rigid tetrahedral arrangement. These all things I have explained in my lecture. Tetrahedral structure of diamond and trigonal planar structure of graphite, tetrahedral structure of silicon dioxide, both having the same type of structure. Diamond and silicon dioxide having a tetrahedral structure. In diamond, each carbon is attached with 4 other carbons. That's why it is called as tetrahedral. In silicon dioxide, one silicon is attached with 4 oxygens. That's why it is called as tetrahedral. 4 bondings. So tetrahedral arrangement by strong covalent bonds where each dash atom has dash covalent bonds. Where each dash atom, diamond having which atom?
Carbon.
Yes,
Carbon.
yes. So by strong covalent bond where each carbon atom has dash covalent bond. Each carbon atom having how many covalent bonds? Here you can see.
4.
4. Yes, so you have to write here 4 covalent bonds. Diamond cannot dash electricity.
Conduct.
Yes, diamond do not conduct electricity. Silicon dioxide do not conduct electricity. But graphite conduct electricity because of the freely moving electrons. So cannot conduct electricity as has no delocalized dash or ions.
Electron.
Yes. Now you are getting how to fill these fill in the gaps. Electrons or ions which are dash to move.
Free to move.
Free
Yes,
to move.
which are free to move. Good. Very good. So these are the answers. Now you are able to fill these gaps. Here I have also written the answers. So those who have missed this can note down the answers from here. Next, we having the short question answers. 10 short question answers. Now answer these questions. What is an allotrope? I explained in my lecture. What is an
Miss,
allotrope?
can I answer?
Yes.
If the term allotrope refers to one or more physical forms of a chemical element that occurs
Yes.
in the physical state, allotrope may show different in chemical and physical properties.
Yes. Allotrope is basically and different structural forms of an element. One element exists in more than one structural forms. They are called as allotrope. So you have to answer it in just a one line that a different structural form of an element. Next is what elements are silicon dioxide made of? Who is going to answer this?
Can
You
I?
have to mention the elements of silicon dioxide. What elements are silicon dioxide made of? Kushbakt,
Miss,
can you answer this?
Yes, miss.
Silicon dioxide having which elements?
Carbon.
No, beta, silicon dioxide. I am talking about silicon dioxide. Musfira, can you
Oxygen.
answer this? Ji?
Miss, can I tell?
Ji, Abdur Rahman, answer this.
Silicon and oxygen.
Yes, you have to just write 2 words, silicon and oxygen. The worksheet was very easy, but you just have to pick how to answer. So answer is silicon and oxygen, simple. You have to write just these 2 words. Are covalent bonds strong? Are covalent bonds strong?
Yes. Can I?
Yes, so the
Yes,
answer
miss.
is yes, covalent bonds are strong. These are just the very short question answers. I don't know why you haven't completed this.
No, miss, I think we were only having problems with the fill in the blanks because I didn't have any problems with these questions.
Good. Question number 4. Describe the structure of diamond and silicon dioxide. Who is going to describe the structure of diamond and silicon dioxide? Pita, who is going to answer this?
Miss, should I?
Yes, Zimal.
Diamond has a giant covalent interlock structure. Similarly, the silicon dioxide also has a covalent structure.
Yes, both having the same three-dimensional structure, three-dimensional network of atoms held together by strong covalent bonds. Simple, you have to answer this question in one line. Both diamond and silicon dioxide have a giant covalent structure with which is a
They
very
have
large 3D network of atoms held together by strong covalent bonds. Clear? Next, question number 5. Can diamond and silicon dioxide dissolve in water?
मिस
No.
J
No.
मिस ये इस वाले का आंसर दोबारा प्लीज बताते हैं वो
I am sharing beta. I will share this video to you and this video contains all the answers. So don't worry. Okay, if you want to write then don't worry, but if you want the explanation, so the explanation for question number 4 is structure of diamond and silicon as we know are same, having a three-dimensional structure. In diamond, one carbon is attached with four other carbons, and in silicon dioxide, one silicon is attached with four oxygens. In the same way, they are attached in three dimension. The same units again and again are attached in a three-dimensional structure. So in how to write, you will get the answer, but this is the explanation. Clear?
Okay.
Next, can diamond and silicon dioxide dissolve in water, Ibat? What do you think?
No.
No, because they are insoluble in water because of their giant structure. They are so compact structure, they are not soluble in water. So you just have to answer the no. Diamond and silicon dioxide cannot dissolve in water. Next, question number 6. Why do diamond and silicon dioxide both have a high melting point?
Miss,
Ji Zimal,
can I answer?
ji bete.
So
Both
giant
diamond
covalent
and
structures.
yes, giant
Yes,
covalent
both having a
bonds.
giant covalent structure and having a very strong covalent bonds between the atoms. That's why you need a lot of energy to break these covalent bonds. In graphite, we need that between the layers of the carbon there was weak intermolecular forces. To break that weak intermolecular forces, you need little bit less energy. But if you want to break the completely strong covalent bonds, you need a very high amount of energy. That's why they're having a high melting point. Next, question number 7. How many covalent bonds do each atom in diamond have? Who is going to answer this? Answer is very simple. You have to tell me about how many covalent bonds are present in diamond with each atom.
Can I?
Four.
Four single covalent bonds.
Yes, 4 single covalent bonds. Simple. Question number 8. Describe how the structure of diamond affects its hardness.
Because of diamond's tetrahedral structure, it seems hard.
Yes, it's very rigid network of carbon atoms held together by strong covalent bonding. Each time you have to explain that there are covalent bonding. Because covalent bonding are very strong, you need a lot of energy. So tetrahedral structure, rigid arrangement of atoms and having all covalent bondings, all strong covalent bonds are present. There are no any weak intermolecular forces between the atoms. That's why it is very hard. Next is, why can diamond be used on cutting tools? As I explained you that diamond is used as a cutting tool to cut the rocks, to cut the hard materials because
Because of
Ibar,
its hard structure.
Because it is hard.
Hardness.
yes, because of the rigid network of carbon atoms, because of the strong covalent bonding. Next, question number 10. Why can diamond not be used as an electrical insulator?
Diamond is a giant covalent structure, which means that it
Because
has no free electrons. That's why it is not a
yes.
good electrical insulator.
Yes. Why can diamond not be used as an electrical insulator? It can be electrical insulator because it do not conduct electricity. So I guess why can diamond be used as an electrical? I guess not should not be here. Diamond cannot conduct electricity as has no delocalized electrons or ions which are free to move. So diamond is a bad conductor, but it is used as an insulator. These 10 questions are answered here. So you can note these or add these answers in your answers. Okay, do not copy these answers exactly. You can get the idea and make your own answers. Now you all are able to complete your worksheets.